All right, so for this problem, we are asked to find a rational zero and use it to find all other zeros of the given function. So take a look at our function that we have here. So typically when solving a polynomial function, if we're able to maybe factor it, maybe do some simplifying in it, we typically tend to go with that. But taking a look at the function that we have here, this is not factorable. And they're asking us to find a rational zero here. So that's kind of a clue here in order to use the P over Q process where we're going to find all possible rational zeros and use those along with synthetic division to test until we find at least one zero that we can use. So that's doing P over Q, where P stands for your constant term here, which is going to be our 8. Over Q is your leading coefficient. Here's a 2. And what you want to do is you want to find all factors of those numbers. So all factors of 8 are 1 times 8 and 2 times 4. It's everything that multiplies to get 8. Everything that multiplies to get 2 is a 1 times a 2. So what you want to do with this list is you want to take everything in the numerator, put it over the same denominator. So for example, 1 over 1, 1 over 2. 2 over 1, 2 over 2, 4 over 1, 4 over 2, 8 over 1, 8 over 2. Simplify all of these. Sometimes we have repeats here after we do some simplifying. 1 over 1 is just a 1. We can drop down that 1/2. 2 over 1 is just a 2. 2 over 2 is just a 1, so we can get rid of that. We don't need to list it more than once. We can drop down the 4. 4 over 2 is just a 2. Again, we already have that. 8 over 1 is just an 8, and 8 over 2 is a 4. Put a plus or minus in front of every single one of these, and this list here represents the possible rational zeros for this function here. So then what we need to do, first we're going to find a rational zero. So we're going to take these numbers here, we're going to do synthetic division, we're going to randomly pick a number until we find synthetic division that works. So for example, let's just maybe start with a 1 and see what happens. I'm going to test a 1. Doing synthetic division, we're going to drop down our coefficients, a 2, a negative 11, a 10, and an 8. And if we do synthetic division here, dropping down the 2, 2 times 1 is a 2. Add this column here to get a negative 9. Negative 9 times 1 is a negative 9. When we add this column here, we get a 1. 1 times 1 is 1. And when we add this column here, we get a 9. That did not help us. Remember, we're hoping to get a 0 here in our remainder column, and that's going to signify that the number we tested is a 0. So since we did not get a 0 in that position, we need to test another number until we find one that works. I'm going to move on to 2. Doing synthetic division again, dropping down the 2. 2 times 2 is 4. When I add this here, I get a negative 7. When I multiply, negative 14. So 10 plus negative 14 is a negative 4. Negative 4 times 2 is a negative 8. And when I add this column here, I get a 0. That is exactly what I'm looking for. That means 2 is one of my solutions. So x does equal 2. Now we need to find our other two solutions. Keep in mind that the remaining numbers that we get here represent the coefficients for our quadratic equation. That means that this is a 2x squared minus 7x minus 4 is equal to 0. With this quadratic equation that we're left over with, we either need to factor it or we need to throw it in the quadratic formula. So I'm going to try and factor this here. So when I factor trinomials, I use the no-fuss factoring technique. So 2x squared, what we're going to do, first step, 2x, 2x. Step 2, take the first number times the last number. 2 times 4 is 8. You want factors of 8 that add or subtract to get your middle term, which is our 1 and our 8. Different signs, minus goes with the 8, plus goes with the 1 here. Reduce one of your factors, so there's nothing in common with a 1 and a 2, so we can drop this down. But over here, we can reduce this by a power of a 2, or a factor of a 2, giving us x minus 4. Split your factors up, set them each equal to 0, and solve here. So we're going to solve these two equations, subtracting the 1 over here, and then dividing out by the 2 gives us our next solution here. X is equal to a negative 1/2, And then by adding the 4 over here, our third and final solution, x is equal to a 4.